Welcome to Homework Lib.
This is chapter 35, problem number 16. We're given the frequency of the light as 6.32 times 10 to the power 14 hertz. And we're given where the third bright fringe occurs, 3.11 centimeter on either side of the central bright fringe. And in part A, we are asked to calculate the distance between the slits. So since we're given the bright fringe's location would be ym r m lambda over d. So first we need to write lambda in terms of the frequency that is given to us, and then r is given in the problem. Where the bright fringe is located is given to us, so we can isolate d and rewrite this equation rm lambda over ym. Now let's go establish the relationship between lambda and the frequency. When they're multiplied, it equals to the speed of light. So then the lambda would be c over f, and then we can plug it in here, c over f, and we also have ym in denominator. Also, it's given to us that this is, well, obviously a bright fringe, but it's the third bright fringe. So m equals 3 in this case. When we plug in all this information, r is 85 centimeters. So let's convert that to meters. And then m is 3. C is 3 times 10 to the power 8 meters per second divided by 3.11. It's in centimeters, though. We need to convert it to meters. And then we have the frequency. So it would be 6.32 times 10 to the power 14 hertz. Then we're going to find out to be 3.89 times 10 to the power negative 5 meters. This would be the distance between the slits. And then in part B, we are asked at what distance from the central bright fringe will the third dark fringe occurs. It is going to be, so since we're talking about the dark fringe now, as you know, the sine theta is going to be equal to m plus 1/2 times lambda, right? But we want to know where it occurs, so we want to know y, right? Y equals r tangent theta. However, we need to get the angle, so we can get the angle from this equation. So sine theta then is going to be equal to m plus 1/2 lambda over d. M in this case, since we're talking about the third dark fringe, m is going to be equal to 2 for the third dark fringe, and we can calculate what sine theta is here. Now, then sine theta is going to be equal to 2 plus 1/2. Again, lambda can be written in terms of c over frequency. So then it would be 3 times 10 to the power of 8 meters per second divided by d. We calculated from part A. It would be 3.98 times 10 to the power of negative 5 meters times the frequency, which is 6.32 times 10 to the power of 14. So from here, sine theta is going to be 0.0305. Now, if we take the inverse of this, right, then we get to the angle, and the angle is 1.75 degrees. This is our angle. Now, if you want to know where it's located, then we do r tangent theta. R was 85 centimeters times negative 2 meters times tangent of 1.75 degree angle. It would give us 2.6 times 10 to the power of negative 2 meters.